Today we're going to look at Learning Target 1.1. Find equivalent expressions or equations by applying different algebraic properties. There are two main pieces in this first learning target that we want to focus on, and one is the distributive property, and one is the idea of combining like terms. So, the distributive property, which you have seen in previous years, says this. It looks kind of confusing, but for any values of a, b, and c, this equation is true. A times the quantity b plus c is equal to a times b plus a times c. Now let's think for a second of why that would be true. If I have 2 times the quantity 3x plus 4, it means I really have two different 3x plus 4s. So I have one 3x plus 4 and a second 3x plus 4, which means altogether I actually have 6 x's and then 8 1's. We don't want to actually have to write this out to add this way most of the time. So the sort of work that you would show for 2 times the quantity 3x plus 4 is to remind yourself you're going to take 2 times the 3x and 2 times the 4 for a final answer of 6x plus 8. Now it's easier to see with positive numbers what you're doing when you have negative numbers. So let's say we're looking at negative 5 times the quantity 4x minus 6. When you distribute this, the negative 5 is multiplied by the 4x for negative 20x. And treat this as a negative 6 when you're multiplying, because 4x minus 6 is the same thing as 4x plus a negative 6. So negative 5 times a negative 6 is a positive 30, so I'm going to write plus 30. So negative 20x plus 30. A last type would be if you have something like, and I'm going to write this down here, if you had something like 4 minus 2 times the quantity 3x plus 7. You might be tempted to do this subtraction, the 4 minus 2 first, but you can't do that because the 2 is connected to the parentheses with multiplication, and your order of operations would say you multiply before you subtract. So in this case, and we'll see more like this in a little bit, the 4 would come down, and I'm distributing, in essence, a negative 2, because again, this is like plus a negative 2. Negative 2 times a positive 3x is a negative 6x. So instead of writing plus a negative 6x, I'll write it as minus 6x. And negative 2 times a positive 7, because of the plus in front of it, is negative 14. But instead of writing plus a negative 14, I'm just going to write it as minus 14. Now we'll look at combining like terms in a little bit, but for the distributive property on this one, that's what it would look like. Now, for like terms have exactly the same variables with exactly the same exponents. So as it says, 3x squared y and 8x squared y are like terms because they both have an x squared and a y to the first, and that's all they have for variables. Because they are like terms, I can do what's called combining them, which means I can add them if they ask me to, or subtract them. I can multiply terms that are not like terms, as we did here. We multiplied a constant of negative 5 times an x term of 4x. They're not like terms, but I could multiply them. When it comes to combining them through addition or subtraction, let's say in this case addition, all I do is add or subtract the coefficients. So if I have 3 of these objects, these x squared y's, and I get 8 more of those objects, those x squared y's, I end up with a total of 11 x squared y's. Now, when I say they have to have exactly the same variable and exactly the same exponent, it means that if I had 3x squared y and the other one was an 8xy squared, those are not like terms. I could not add them together. While they both have the variables x and y, the exponents are not the same. These properties of equality we won't be using as much in this section. However, they will become very important when we're looking at our next section, Learning Target 1.2 and 1.3. And that basically says if I have an equation that is in balance, I can add the same thing to both sides of the equation and the equation's still in balance. Or I can divide both sides of the equation by the same thing. So you're going to be seeing these properties of equality more later. Now it says use any combination of properties above to write three different equivalent equations, so equations that have the same value as this, to y equals 3x minus 2 times the quantity x minus 6. Now the first thing I'm going to do is just, and you don't need to do this, but I'm going to bring this down and recopy it so that I have room to work, because it's kind of hard to write with this thing. Again, I can't take the 3x and subtract 2 from it because they're not like terms. This has an x and this doesn't. But even if they were like terms, I wouldn't do this subtraction before I do this multiplication. So I'm going to change to blue for my first equivalent equation. The first thing I'm going to do is the distributive property to get rid of the parentheses. So y equals 3x. I'm distributing a negative 2 because of the minus in front of the 2. Negative 2 times a positive 1x is a negative 2x. So I'm going to write minus 2x. Negative 2 times a negative 6, because of the minus in front of the 6, is a positive 12. So I'll write plus 12. That's my first equivalent equation. My second one, let's take a different color of black. For my second one, I could combine like terms. The 3x and the 2x are like terms because they both have the variable of x to the first power, and those are the only variables they have. So y equals 3x minus 2x is 1x. We just don't usually write a 1 coefficient, so 1x is just written as x. And then I'm going to bring down my constant of plus 12. I can't add it and combine it with the x term because this is an x term and this is a constant. Now we're going to use one of our properties of equality to get a third equation out of this. And you won't be expected to do much of this one. But the addition property or subtraction property of equality, depending on which one you're going to choose to use, I'm going to use the subtraction property in this case. I'm going to decide that maybe I don't want this constant on the right side of the equation. Well, to eliminate it on the right side, since it's a plus 12, I would subtract 12. If I subtract it from one side, the subtraction property of equality says I can subtract it from the other side as well, and then my equation will still be in balance. So my third equation is going to be y minus 12 equals x. So three different equations that came from the same first equation. Now, for tonight, you have an assignment from the book. So please look at your note sheet and do that assignment. Thank you.